So I appreciate the opportunity to talk to you guys today. So Ronnie asked me to provide the presentation that I had I've given yesterday before the COVID-19 virus. It was supposed to be the IoT World Forum in New Orleans. It was supposed to occur yesterday. Of course, it was virtual, and so I gave the virtual keynote yesterday, and so I'm going to be giving you the same presentation that I gave yesterday at the IoT World Forum, and it was specifically around. I've been giving a series of talks at these IoT conferences around what I call the age of autonomy. I believe that autonomous systems are going to become more and more prevalent. There's going to be more and more interactions between robotics and humans, whether that's in a autonomous vehicle setting, a smarter city setting, etc. And so yesterday I gave
So
the
Matt,
most
just
recent.
one thing. We cannot see you through webcam. So if you could turn on the webcam.
Well, let's give it a shot here.
So at the
Let's
top,
start
Charlotte,
sharing.
can you suggest how to activate that one?
Yeah, it should.
Yes,
It
I
should.
think
Is it? It says it's. It says that it's working, but it's not showing anything.
camera should.
Yeah, for some reason it's not working, Ronnie.
I think that's fine. You can present it. I think that's fine.
Yeah.
Thank you.
All right. So so let me get back to this real quick. All right. So as I was saying, yesterday I gave this presentation to that worldwide conference, and in particular, what I'm going to focus on today is what I believe is a need for a fundamental shift in the way that solutions are architected. Since the beginning of the internet, the solutions have been done in a very centralized, traditional enterprise IT kind of fashion. And I believe very strongly, my point of view is that in order to meet the challenges of the next generation of solutions in this age of autonomy, we're going to have to fundamentally change our approach and change what we do, including the internet itself. The internet was built for primarily stationary things, very static things, and that's not the world we live in today. So I'm going to be talking about those kind of fundamental changes that we're going to have to make. And so for some of you may recall, that there was this famous saying back 7, 8 years ago about software is eating the world. And my assertion is that if software is eating the world, autonomy is going to eat the universe. Significant change in the capabilities of what we're going to be able to do, things that today we just simply think are beyond our scope in terms of scale and performance, etc., are going to be within that scope if we make this transition, this pivot to the decentralized architecture. But in order to do that, we can't continue to do the same things that got us here over the last 30 years. If we do that, that's the definition of insanity. We're going to get the same results. Today, if you look at the systems that are built, they're built not for millisecond response time. They're not they're not context sensitive. They don't have precise location. The systems that were built 30 years ago from an architecture that was very centralized are not going to be responsive enough. They're not going to have context sensitivity enough. They're not going to have actionable feedback enough. And they're not, we need to move more to this coordinated swarm-based model that I believe in. This isolated, centralized model has served its purpose well, but if we continue to utilize that, we're not going to get different results than what we get today. And so the analogy that I think kind of most equates to this is that of the human body. When you look at, when people talk about neural networks as an example, they always have this diagram of the cranial nerves there. But the cranial nerves in the nervous system of the body, there are 12 major nerves there. When you talk about the body itself in terms of the nerve cells, you have hundreds of billions of nerve cells. You have a peripheral and an autonomous nervous system that's in play there. And in order for us to break out of what we're in today, which is processes that are buried in people, paper, and process, architectures that are buried in having to supplement what we can do in a centralized thing, we move past a centralized out into the landscape where things need to happen near the source of the data. We try to augment what we can do in a centralized fashion with people, paper, and process, and it doesn't work. You have to look no farther than the COVID-19 outbreak. The lack of visibility across supply chains, as an example. All the supply chain solutions that are out there today are very centralized in nature. And when you have centralized visibility only, and you don't have a real-time visibility throughout the supply chain itself, then you're making decisions based off of guesswork. And so many times when people talk about autonomy, what they really are talking about is kind of next-gen analytics and automation. That is not what I'm talking about. I'm talking about a fundamental shift in the way solutions are built from this centralized model that we've had in place with internet and solutions and enterprise IT space to a decentralized, real-time solution architecture, which is responsive, adaptive, context-sensitive, has coordination of multiple parts working together in unison, is location aware, can have learned behavior in real time, and is very much decentralized. And so this brings us to what we are calling kind of the Internet of Moving Things. When you look at kind of the new apps and the new requirements that are out there, you're talking about nanosecond timing. You're talking about micro positioning that needs to get down to 10 centimeters or less. You're talking about guaranteed connectivity of less than 10 milliseconds. You're also talking about motion critical data. The internet has served us well and has been optimized as best as it could with the traditional kind of centralized model. But in order for us to get to the next generation of solutions, we're going to have to fundamentally shift that model in order for that to be successful. And so when you look at one of the most important aspects of that is location. Location does matter. When you talk about retail, when you talk about real estate, everybody always says location, location, location. Well, in my assertion is that location matters, and it matters a lot. And you need to have more and more precision in your location. And things that are intelligent that you can bake into a particular location, it might start out serving only a specific purpose, like, for example, a light bulb. But you could, because you have that smart device at that location, you may be able to utilize it for other purposes than it was originally designed for, because it has access to real-time behaviors around it. And so when you look at some of the things that are happening on the IoT front, you have massive numbers of smart device manufacturers that build a smart device for a particular usefulness in a particular location that are now looking at, wow, I've got an advantage because I have intelligence at that location. How can I utilize that advantage of that location in a new and different way? And so I think one of the positive things out of this COVID-19 outbreak is that you're going to see a flurry of innovations around location-aware IoT devices that can provide additional data above and beyond what they were originally designed for, just because they have unique visibility because of the location that they're in. And that leads me to the place where my team's been spending a lot of time lately. So one of the privileges I have on the IBM side is that not only am I the partnership executive for the relationship between IBM and Clemson and the relationship between IBM and MIT, but I also own the relationship with NASA. And so our work with NASA over from an IBM perspective, goes all the way back to the beginning of NASA. Last year, we actually celebrated the 50th anniversary of the Apollo 11 mission, the landing on the moon. And so IBM has a broad history working with the public sector in space, in particular NASA. What we've seen, and you probably have noticed all SpaceX and the other private industries that are getting into the space tech industry, there's this great convergence, if you will, between the public space agencies and the private space agencies as it relates to trying to utilize space as an additional value proposition on Earth. So, an example, some of the projects that we've done over the last few years working with NASA are Earth observation. In other words, utilizing low orbit satellites to get a perspective on the ground, what's happening on Earth, that can then augment the information that you're getting on the ground, the Earth data that you're getting, mixed with the space data, gives you a greater visibility of what's happening. We also have been doing quite a bit of work with space weather meets Earth weather. In other words, I've got space anomalies that are causing changes in the weather in space, and those changes are going to have an effect, spillover effect, if you will, on Earth weather. And then we've also done quite a bit of work around with the mission to Mars, utilizing AI for astronaut health. But that's what we've done in the past couple of years. But what we're focusing on this year, the projects that we have are the ones that I have on this slide here. The number of satellites that are being launched, both either publicly or privately, continue to grow, and there's really no rules in space. So in terms of situational awareness, being able to do predictable space debris collision calculations, it's a very difficult problem that needs a new approach to solve, because if you're trying to avoid collisions and you're relying only on the feedback from a single satellite, from the single view that satellite has, and that's got to travel all the way back down to Earth and get analyzed, and then the response goes back, by then the satellite's already crashed, especially as you get more and more debris and more satellites up there. And so the space tech industry in particular is really pushing us towards this decentralized model. And I think that's also true if you look at the examples around smarter transportation, autonomous vehicles, smarter cities. When you look at traditional type of guidance systems inside of automobiles, you're talking about GPS-based mapping systems, etc. Those mapping systems are traditionally accurate within 10 meters. Well, if you're 10 meters off in terms of your accuracy in an autonomous vehicle setting, you just wiped out a sidewalk and killed a whole bunch of people. So it's not precise enough. And what really matters is not necessarily the location of your individual vehicle, but very much like the satellites here, it's the location of your vehicle in the context of the other entities that are around you, the other debris, the other satellites, etc. And this aspect of a swarm behavior, like I was saying before, the coordination of the location and the synchronization of the timing is going to be what's really important and really critical. Now, we're in the middle of this explosive growth around data and devices. It's anticipated that there's going to be 75 billion connected devices to the internet by 2021, 44 zettabytes of data by 2021. And what's really interesting here is that we continue to get more and more devices, more and more data. We continue to get more and more geographical distribution of that data. But today, even before we have some of these new solutions, even in the existing centralized solutions that we have today, 60% of the data loses its value in milliseconds. And because we are working in a centralized fashion and we can't be responsive in real time, that value is lost, which equates to 90% of the data that is gathered today is not used, right? And that data continues to grow. That percentage of data not being used has actually been growing. It used to be 80%, now it's 90%, because the centralized systems that we have today, they can't handle the volume of data. They can't handle the velocity that's needed for the insight from that data, and they can't handle the veracity of that data, the changes of that data. And the reason for that is if you look at the decisions that are made, they're still very much, going back to my previous chart, buried in people, paper, and process. There's human decisions that are introduced in here. If you go back to my supply chain example, which is, I think, a good one, you have multiple companies with lots of people that have to interact with one another in order to get the simplest tasks done. And what ends up happening is, to understand how to optimize supply chain problems today, often they take days or even weeks because of the people, paper, and process that those systems are buried under and the centralized nature of the system. And what we've seen over the last few years is a move towards more of complex event processing, streaming analytics. But what we really need to get to is these cognitive decisions. In other words, autonomous decisions that are made off of the data. But the autonomous decisions are only going to be as good as the data that they're making them on. And they're only going to be as good if they can adapt to changes in that data. So one of the things that I was fortunate enough to do on the IBM side is that 4 years ago I got to lead the IBM acquisition of the weather company. Now that was a very unique acquisition for IBM. I remember when I took that into my senior executives, I think they thought I was crazy at first because, why would IBM want to be interested in the weather company as an acquired asset? Well, for one, weather was the largest data set in the world, and it had a significant a number of data scientists that did real-time data analytics, cognitive AI. You might notice that on your phone, on your weather app, it says that it's an IBM business. It also, you will notice that you get weather alerts now that tells you the exact minute that it's going to rain in your area. I remember growing up, it was a common joke for the weather man or woman to say they were the only person that could have a job and only be right half the time and still keep their job. The reason why the weather company was able to get to that level of precision was because of the fact that we crowdsourced the weather data. It used to be that weather forecasting and modeling was done based off of the input that we got from devices that were owned by government entities that collected weather information. And so you're talking, in the United States, you're talking about maybe a few hundred devices overall that the government had that we collected weather for. What we did was we created the Weather Underground, which basically crowdsourced weather information, which meant that individuals with weather kits could get a weather kit, collect information that was very local to them, and then what we did was we trained our models based off of that real-time data, and we pushed that information out. So our models went from a centralized approach to a decentralized approach. It went from we did 2 weather forecasts a day at 12 hours intervals to every 5 minutes we'll do a forecast and we'll do a different model. And that's the world that we're going to live in. It started with weather because of the fact that weather is such an open data set that everybody's willing to share weather, everybody wants to have weather information, etc. But the lessons that we learned there we're now applying to other use cases. And so when you look at the architectures, like I said before, that large companies have traditionally built systems around, they're all centrally controlled, they're all centrally delivered, they're static, they're reactive, they're operationally intensive. And what we need to move to is this next generation service delivery is a more of a peer-to-peer, decentralized, and open multi-cloud, edge-enabled AI kind of model where we can make decisions in real time and we can scale. One of the other big problems with the traditional enterprise IT solution architectures is the fact that in order to handle the volume of data, in order to handle the volume of systems activity, people had to build systems and they had to plan for a certain level of capacity. Well, they couldn't afford to build to the very worst case scenario. And if they built to the best case scenario, then if anything bad happened that changed the normal traffic patterns, then they ran into issues and problems. So most people just tried to hit it somewhere in the middle. It was very much guesswork. And so you see that with the COVID-19. A lot of our healthcare system is still on, it's almost all on-prem. It's almost all centrally controlled, centrally operated, static, et cetera, which meant that when you had something like a pandemic, the system can't handle it. And so what we have to build to is we have to move towards this decentralized model such that we can plan for, quote, infinite scale. We can plan for instantaneous need to change and provide feedback and insight. And that's going to be a very difficult transition because there's been 30 years of building it one way, and we've got to move to a different architectural model. And this is why the edge becomes an essential element here. So right now, we have the traditional Gartner hype cycle. Edge is at the top of the hype cycle. If you turn the clock back maybe 7, 8 years ago, cloud was on that hype cycle. And then maybe 5 years ago it was AI. And maybe 3 years ago it was IoT. Now it's edge. And see, edge is having the ability to provide the intelligence at the edge. So think of it as taking what we were able to do with cloud. When you look at cloud computing, when you had traditional enterprise IT system with a fixed amount of capacity, what cloud gave you the ability to do is to consume capacity as you needed it. So when you needed more capacity, you could get to it very quickly and easily versus having to buy systems and build implementations on that. And over time, as cloud has matured, people have come to expect the ability to get compute on demand, storage on demand, et cetera, so that you can get to additional enterprise IT. But it's still, even with the traditional cloud computing that we have now, it's better than what you could do on your own. If you were the only one that had to buy all these machines, now you basically are paying for these services. You still, because of that centralized model, there's still the latency and bandwidth issues between data that's generated remotely and the need to respond. Going back to what I said before, 60% of the data that's generated, in order to have its full value, it has to be responded to in milliseconds. You can't do that with a traditional centralized model, even with a flexible cloud model, because you can't get around basic physics like the speed of light, as an example. And so being able to push that intelligence, so think of it as cloud computing in some ways being stretched out to the edges, having the ability to be able to build technical capabilities and intelligence at the edge that can respond. One of my friends, who's an avid golfer, says it's like playing golf. Hit it where it lies. In other words, if the data is being generated somewhere else, then go and take the insight, take the analytics, take the AI to where the data is. Stop trying to move the data. I've seen so many customers. I even saw one customer that I won't name by name, but it's a federal customer, a government customer, that actually has denial of service boxes in front of their data center to block their own traffic from their IoT devices that are out in the system because they can't handle it, right? They turned on these IoT devices because they needed this data, but they can't handle the volume. And so what they did is they actually blocked the data from coming in because they couldn't handle it. What if they could actually handle the data, but handle it local to where the data is being generated and be able to reshape and relearn the models and be able to do reinforced learning and learn behavior at the edges such that they didn't have to always go back to the back-end systems to make a decision. So that's why the edge is becoming so important. Because what we need to do is we need to be able to amplify human intelligence with AI. But in order for AI to be fully successful, AI is only as good as the data, and the data is only as good as the architecture that allows you to access the data. And it's my assertion, like I said many times here, that in order for us to get to making objective decisions versus subjective decisions, so many people basically get around their data volume problem by doing samples. So they'll take a sample size from a particular source. But how big a sample do you make? How often do you take the sample, right? What if during your sample interval, the thing that you really needed to know happened, so you missed it completely? Those kind of models are very subjective. You're doing guesswork based off of what you think might be happening versus what actually is happening. And so, the best AI modeling data science team in the world is not going to be able to build an accurate model that if it's not based off of real-time data that's actually providing insight to what's happening, where it's happening, and when it's happening. And so that's why, fundamentally, there's things that got to change in the way we approach this. And then I want to talk a little bit about blockchain. So I talked about supply chain a little while ago, and supply chain is a great use case because when you take a look at some of the issues that I talked about with centralization and the problems that it can cause when you're talking about a massive scale and the need to be able to respond in milliseconds, you take that and you have exponentially complicate things when you go to the supply chain, because you're not only just now dealing with one customer and their own data and their own centralized implementation, but now you, on a supply chain, depending on the complexity of that supply chain, it could be a dozen or more different companies that need to share information and share data. And the problem is each one of those companies has their own process, their own people, their own kind of paper kind of orientation of how they do things, and they have their own data, and it's all siloed. So if you take a look at things like healthcare and government and finance, those things are the reason why it takes so long to be responsive is because when you have multiple entities that need to work together, and in particular, like in the case of the COVID-19, you have healthcare needing to work with finance, needing to work with government, and then you have all these supply chain problems. It's really brought to light some of the issues that I'm talking about here in terms of we've got to move to a digitally enabled process. We've got to digitally enable the flow of information. We've got to be able to secure the exchange of data and information so that we can get an aggregate view across the supply chain between partners such that we can make the right decisions. And that's why blockchain is really interesting, because it's a decentralized technology. It's built such that it's built for this kind of peer-to-peer decentralized type of interaction. And so it's very promising to take those processes like supply chain that are buried in people, paper, and process and digitally enabling them such that you can have shared ledgers and contracts that can all be done digitally and programmatically in real time versus having to have, middlemen in the process, in the flow to mitigate some of these things. So what we've seen is this significantly improves the flow of information. So, like as an example, one of the solutions that IBM came out with was what we call the Food Trust Network. So I'm sure all of you went to the supermarket and you couldn't get iceberg lettuce because there was some E. coli outbreak in an iceberg lettuce farm in California. All right. And so what do we do today? Well, there's no visibility across the supply chain, so they cancel. They say basically the FDA puts out a thing that says nobody can eat iceberg lettuce, nobody can sell iceberg lettuce for a month until they clean out everything that was in the supply chain at the time when the outbreak occurred, because they lack visibility, traceability of knowing where that one farm that was infected with E. coli, where did that lettuce go? They have no visibility of that. And so because they have this tremendous waste that happens in the system. And so we created the Food Trust Network so that we can have the ability to trace every single point where the food went across the supply chain such that we knew exactly where the lettuce came from that particular farm and which stores had that lettuce and where it was sold. And you could actually do that in a very optimized fashion versus the massive waste that we get through the old model. And that's because it was decentralized and because it utilized decentralized technology like blockchain. And so kind of before we get to a Q&A, I wanted to kind of tie this all together in a nice, pretty little bow, if you will. You have blockchain, which basically provides the real-time governance for collaborative data exchange. And many times people, when they talk about blockchain, I should have mentioned it on the previous chart, is they think about blockchain in terms of a shared ledger, smarter contracts, and yes, it is that. But it's also a new way of providing security and credentials. So in other words, I can, through a zero trust model, I can make sure that I have the ability to establish trust and the terms and conditions around that trust and allow me to exchange data along those terms and conditions of the smarter contracts such that I can interact with entities that I currently couldn't do today because I lack an established trust with that particular entity. So lots of interesting things in terms of governance and security and collaborative data exchange. And one of the things that we've been working on with MIT is this aspect of a trusted data exchange. So there's a consortium that MIT and IBM founded a few years ago called the Trust Data Consortium. And that's the intent is that to utilize blockchain technology for that kind of secure data exchange. And then we use AI to provide that real-time objective insight, action-based on analytics in real time, and utilizing making objective decisions, not subjective decisions. So I'll give you a great example of that. Going back to the weather company example, the first solution that the weather company came out with in terms of AI was with the airlines. They went to the weather company's based in Atlanta. They went to Delta Airlines, and they basically said, we're already giving you real-time weather forecasts for your pilots. We'd like to provide you information about turbulence. And Delta said, well, thank you very much, but we have the best pilots in the business. We know how to handle turbulence. And so the weather company says, well, why don't we put 20 weather turbulence sensors on your plane, and we'll analyze the data through our AI system, and we'll provide you information of that free of charge for a year, and we'll compare what you would have saved if you listened to the AI versus the pilots. But what they ended up finding out at the end of the year that the pilots had a natural bias, if you will. Pilots that came from a military background consistently underestimated turbulence on the turbulence scale. The ones from a civilian background consistently overestimated turbulence. All right? And because of that, that meant that if you're underestimating turbulence, you're not putting planes in maintenance that should have been. And if you're overestimating turbulence, you're putting planes in maintenance that didn't need to, and also flying planes around turbulence unnecessarily. And so the calculations came out to be about $10 million across the airline if they'd listened to AI versus the human bias, the subjective decisions, and making them strictly on objective decisions. And to Delta's credit, they rolled that out the next month, and now every single airline in the U.S. Implements that same system. So that gives you an idea of if you can get to objective insight with real data in real time, you can make a significant difference over utilizing kind of human subjectivity. And then the edge provides that precise location and timing. Timing is really critical here. I talked about location, 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 but timing is just as important. I need to be able to know how things are moving together. It's like think of a smarter city setting as a living, breathing organism, and that needs to interact with one another in real time, just like the human body, going back to my analogy does. And so we believe that these systems working together are kind of the age of autonomy is kind of upon us here. And we believe that with the right changes, adaptations in the solution architecture, moving towards this decentralized model, we're going to have significant better results from things like AI than we can get today with the centralized model. So I'll stop talking, and then I'll take questions.
Please write down your question if you have any in chat room. I think someone is writing down in the chat room.
No questions? Okay. All right, so the question was, what do you think will come after the edge computing era? So it's interesting you say that because I almost included it in this presentation. One of the things that we're doing, going back to the work that we were doing with Space Tech that I was mentioning with NASA, is that we're doing quite a bit of work with around edge computing there. But the next thing that we're looking at is actually utilizing our quantum computers. So IBM has our IBM Q, which is our quantum computer, and quantum services. And we are currently looking at how we can incorporate quantum technology into some of the solutions that I talked about. So we will shortly be entering over the next 5 years the quantum era as well. So that's a good question. Do you think about the prospect of software-defined networking and implementing the decentralized system? So that's another great question. So yes, absolutely. In fact, the presentation that I gave yesterday, excuse me, at the IEEE IoT World Forum, one of the other speakers was a friend of mine. His name's Cole Crawford. He is the founder and CEO of a company out of Austin, Texas called Vapor.io. And Vapor is an edge data center company. And so this technology that he's doing, he calls the kinetic edge, and it is heavily utilizing software-defined networking.
Sorry, so how was the SDN was used, the software-defined networking in the application? So how they use the software-defined networking?
Yeah, go ahead.
For their application?
Well, so Vapor is a micro data center company that has a lot of networking expertise, and what they do is they drop in these they call them vapor chambers they're actually funded by Crown Castle, which is the real estate investment company that owns all of the real estate where all the cell towers are in the United States. And so the reason why they funded Cole's company was such that they want to be able to drop these mini data centers on location at the 5G cell aggregation points, and then provide a set of services into the smarter city. And the way that they can do that,
so Mike, I have one more question.
Wiring,
so we are using cloud computing, so we have the commercial cloud servers, Amazon or Google. But now, so for that we are looking at the Amazon server, but how do we integrate that with edge computing, say for mobility application? So what will be in our edge? So because we cannot have a commercial server on the edge, so how we will integrate the edge computing with the commercial servers?
Yeah, so that's a good question. So if you look at the level of maturity that exists today in the market, you have lots of edge computing, which are really doing nothing more than acting as a gateway between the IoT devices downstream and the cloud upstream. What we see in the future, and Vapor is kind of one of the companies that's kind of the leading edge of that front, is building intelligence, moving that intelligence that's today traditionally been back in the data center out to the edges in these kind of micro data centers, mini data centers, if you will, at the 5G aggregation.
So
that is a progression of maturity that hasn't quite hit the market yet.
Use that like in the same
that's
fashion,
what we'll see in the future.
Those same edge computing and fog computing?
Well, so that's another good question. So the term fog computing was actually coined by Cisco back in 2014, 2015 at the IoT World Forum that they hosted in Dubai. I actually was one of the keynote speakers at that conference with some of the Cisco folks. And that's where they unveiled their fog computing, and a lot of other companies kind of took that fog. And what they mean by, like Cisco, when they talk about fog computing, the reason why they picked fog, and quite frankly, probably because the reason why Cole picked vapor, is this thing of stretching the cloud, if you will, down to the edges. So the cloud's coming down to the edge, to the location of the actual source of the data, versus being in a centralized fashion. So, sometimes when people are using the term fog computing and edge computing, they're talking about the exact same thing. Sometimes, like Cisco, when they talk about fog computing, they're actually talking more about an edge gateway versus an actual, a networking function, if you will, only, versus compute, storage, and other services kind of function. So sometimes when people talk about fog, they're talking about a subset of the edge.
Confuse the edge computing, but sometimes so this server, the cloud computing needs to come to the edge. I think that's what Vapor is working on, right? Actually really bringing it to the edge.
Yeah, so that's correct. The fundamental difference is, when Cisco talks about fog computing as an example, they're basically talking about doing a lot of things on the networking side in terms of SDN and other things at the edge of network that interact with the centralized system, versus actually doing the intelligence at the edge. They're just being optimized in terms of how they're interacting between the edge and the backend system, not moving the things that traditionally were done in the backend system out to the edge. So that's the kind of the difference between the two, if you will. Yeah, so it says how does edge computing benefit from autonomous vehicle applications? So it's really interesting in terms of autonomous vehicles because it's the ultimate use case for edge computing. Everybody realizes pretty quickly that this aspect of what I talked about with swarm intelligence is important. In other words, it's not, you can't have all this intelligence just baked into a single vehicle and be able to solve all the problems, collision problems, safety problems, security problems, etc. It's the coordination of the information from that vehicle and all the other things around it. And so this aspect of swarm behavior that I talked about is going to be really important. And so you have all of these autonomous vehicle applications that have, because of their location in the vehicle or in a light post or whatever, they have tremendous value in terms of precise location information and timing information that they could particularly provide applications such that you could avoid collisions, optimize traffic, etc. So there's this nice symbiotic relationship, if you will, between those kind of autonomous vehicle applications and edge computing, such that the edge computing push out basically provides a smarter, intelligent infrastructure that's close, such that those autonomous applications in the vehicle can interact with it and make better decisions. And then there's the flip side of that, those applications providing data that's more real-time and more location context and allows the edge computing framework that's doing AI and other things to be more intelligent. So